So, Chapter 12 is about liquids and solids and intermolecular forces, which are the forces that hold those states together. I like this quote from Roald Hoffmann. It's a wild dance floor there at the molecular level. When we learn more about what matter is and how it behaves, we realize that even the matter that appears to be solid and stationary is actually in constant motion, which is kind of weird when you think about it. There's a link here to a very cool video, and I don't think we need to watch that together, but I would encourage you to go and watch that. You can get there through the PowerPoint slides. I think the video is also on the playlist. I'll have to double check about that. Or you can watch the video from last semester where I did record us watching that. But this picture kind of summarizes it. This is an astronaut on the space station doing an experiment requested by some school children in Canada and looking at what happens with water in no gravity. And he takes a washcloth and gets it soaking wet and wrings it out, and it behaves very differently than we see it behave on Earth. And the reason for that is intermolecular forces. And so here in this picture we see this very large drop of water, and it's forming an almost perfect sphere. So intermolecular forces is a very important topic because this explains so much behavior of matter. As the name suggests, intermolecular means between molecules. So these are different than chemical bonds. These are not covalent bonds or ionic bonds or metallic bonds. These are between molecules. They can be between atoms in an element as well. These are significant only at very short distances. If there were no intermolecular forces, there would be no liquids or solids. Everything would be a gas. They're also essential for physiological processes. So I know a lot of you are much more interested in biology than I am, but I do like biochemistry. Oh, hey. Look, I have a visitor. This is Bartholomew. Yeah. And Frank's down there too. Hey, Frank. This is Frank the Fearless, Bartholomew the Brave, and Frank the Fearless. Hey. What did they... Yeah. Cats. They're very young, but they're still attracted to keyboards. Okay. So, as I was saying, before I was interrupted by the biological organisms, many of you are a lot more interested in biology than I am. I do like biochemistry. And in biochemistry, we look at at things like proteins and how their shapes come about. And a protein is a very long, large molecule, and it coils up in a particular way due to intermolecular forces. Your DNA is held together by intermolecular forces. So super important for physiological processes. So the state of a sample of matter is going to depend on the relative strength of the intermolecular forces. The strength of those relative to the amount of thermal energy. So thermal energy has the particles moving, and that kinetic energy tends to cause them to move apart from each other, whereas the intermolecular forces are going to hold them together. And so whether something is a solid, liquid, or a gas depends on which set of forces is winning. Now don't chew on the keyboard cable, go away.